Alright, so here we have a beautiful question based on the equilibrium constant, and this is just like a puzzle game. Let's see how we're gonna solve this out. Fine. If you observe the reactions carefully, what do you see is N2O2 is present only in the first reaction. Okay. Now, if you observe reaction 2 and reaction 4, they're exactly reverse of each other. Okay. Okay. Let's take a general case, reactant converting into product, right? If I write the K equilibrium for this, it will be concentration of product upon concentration of reactant. Make sense? What if I reverse the reaction? Product converting into reactant. Now if I write the new K equilibrium dash, it will be concentration of reactant upon concentration of product. Make sense? Okay. Now if you just multiply K equilibrium into K dash equilibrium, what you will get is product by reactant into reactant by product, and everything will get cancelled. It will be 1. So can I say that the new K equilibrium dash will be inverse of K equilibrium? So let's draw the parallel here. If you reverse the equation, the new K equilibrium will be reciprocal of the K equilibrium. Make sense? Okay. So now observe reaction 2 and 4. They are exactly reverse of each other. In reaction 2, half N2, half O2 forming NO. In reaction 4, NO dissociating into half N2, half O2. So can I say K2 into K4 will be equal to 1, or K2 will be 1 by K4? Look at the options. We have one clue. None of them is matching, right? Okay, but we have K2 into K4 is 1. That's one relation that we have. We need to find out the relation between K2 and K3, K3 and K4. Okay, fine. Let's go. Okay, look at the reaction 3 and 4. Reaction 3 and 4. What do you see? If you multiply reaction 4 with number 2, you are going to get reaction 3. What do I say? That if you multiply reaction 4 with 2, you are going to get reaction 3. Let's take the general case again. Let's say reactant is converting into product. The K equilibrium will be nothing but concentration of product by concentration of reactant. Make sense? Okay. If you multiply this reaction with 2 reactant converting into 2 product, the new K equilibrium, what is the formula for K equilibrium? Concentration of product raised to power their stoichiometry. You have to remember that. So concentration of product square upon concentration of reactant square. This will be your new K equilibrium, right? Okay. So if you just put this value, so this will be concentration of product by concentration of reactant whole square. This is nothing but K equilibrium whole square. So let's draw the parallel again. If you multiply the reaction with a number, the K equilibrium will get that power, right? The number as the power. You multiply the reaction by 2, the new K equilibrium will become square of that. If you multiply with 3, the new K equilibrium will become cube of that. If you multiply with number n, the new K equilibrium will be n times, or the power of that K equilibrium as n, right? Okay, makes sense. Now come back to the question. You have reaction 4 multiplied by 2 to get reaction 3. So can I just say one thing, that my K4 will be nothing but, what will be the relation between K3 and K4? You have multiplied K4 with 2. So K3 will be nothing but square of K4. Make sense? Is it okay? Cool. And you already know that K3, I want to find a relation between K3 and K2, or K3 and K4, right? So that's the relation. K3 is square of K4, and that's what exactly I see in option A. Okay, K3 is square of K4. I want to find a relation between K3 and K2. Okay. So can I just do one thing? If I put the value of K4 over here, what is the value of K4? From this equation, K4 is nothing but under root of K3, right? Okay. Now if I put this value over here in this equation, K2 into, instead of K4 I'll write under root of K3 is equal to 1. And that's what the equation is. Make sense? And that's what I see in option B. Under root K3 into K2 is 1. So yes, A is correct, B is correct. So that means both A and B are correct. So the right answer is neither A nor B, but it is option C. I hope you can see the right answer. And with that, we conclude this beautiful question. And if you want to rate this question on a degree of 3 stars as a difficult question, 2 stars as a moderate question, and 1 star as an easy question, I'll rate it as 2.5 star. Why? Because the options placed are very beautifully. Right? Thank you. And with that, we conclude this question. Alright, so here we have a question that is based on the pKa and the pKb values. Some data is given to you, pKb for fluoride ion at 25 degrees C. That's an important thing, you know. At 25, you know the value of Kw, that is minus 14, 10 to the power minus 14, and the pKw becomes 14, right? So the pKb given is 10 to the power 10.83, and you have to figure out the ionization constant of the hydrofluoric acid, right? Okay. So can I just say Ka into Kb is equal to Kw? We know this is for a monoprotic acid. So if I just take log on both the sides, I'll write it as log Ka into Kb is equal to log Kw. Make sense? Okay. So if I just use the property of log A into B as log A plus log B, this will be log Ka plus log Kb is equal to log Kw. Let me take minus on both the sides. So this will become minus, this will be minus, and this will be minus here. Minus log Ka, nothing but pKa, plus minus log Kb, nothing but pKb, and minus log Kw will be your pKw. So pKa, first I'll calculate pKa from this equation, then I'll convert that pK into Ka, and that will be your final answer. So pKa plus pKb, this is not Ka, this is Kb, right? Okay, 10.83. Okay, and pKw, because temperature is 25, Kw will be 10 to the power minus 14, pKw will be 14. If you solve this, pK will be 14 minus 10.83. Okay, so this will be like what? 4 minus 0.83. Why am I not writing 3.17? There's a reason behind that. Why? Because I need to calculate the antilog, right? So if I just solve this, pK will be minus log Ka. So if I take minus on that side, so I'll write it as log Ka is equal to minus 4 plus 0.83, right? Because I need to calculate the antilog. So can I just write this as 4.83, right? This is minus 4 plus 0.83. This is the notation. If I take antilog, log on that side or antilog on both the sides, K will be antilog of 4.83, minus 4 plus 0.83. Right? And that's what the value is given in the equation. What is the value? 6.76 into 10 to the power minus 4. This is your Ka, and this is the ionization constant of the hydrofluoric acid, right? So the answer, final answer is 6.76 into 10 to the power minus 4. I hope all of you can see the right answer. Thank you. So here we have an amazing question, and this question has a lot of concepts involved in that, and let's see how we're gonna deal with that. Fine. So the density of the mixture is like a mixture of gases, CO and CO2, and the density is 1.5 gram per liter. Fine. The pressure is 73 centimeter of Hg, and the temperature of the mixture is 303 Kelvin. Fine. You need to find the mole percentage for CO and CO2. Cool. Okay. So you know the formula for density is PM by RT. And if you do not know, it is very simple. We'll quickly just derive this. PV is equal to nRT. Can I write N as W by mRT? If I take volume on the other side, pressure will be like W by V into M into RT. So W by V is nothing but density. So pressure will be dRT by M. So from here M will be what? dRT by P. Make sense? Okay. If you just solve this, the molar mass of the mixture will be dRT by P. So the density is 1.5 gram per liter. Remember the units. R, the gas constant. Let's take pressure in ATM. So the gas constant will be 0.0821 liter ATM per Kelvin per mole. Okay. Into temperature is 303 Kelvin. Upon the pressure. Pressure is given 73 centimeter of Hg. If it is like 76 centimeter of Hg, it is 1 atm, right? That's what we know. 760 mm of Hg or 76 centimeter of Hg, right? If it is 73 centimeter, it will be like 1 by 76 into 73, and the pressure in atm is 73 by 76. If I just write it as 73 by 76 atm. Liter, cancel with liter, atm with atm, Kelvin with Kelvin, I am left with gram per mole. That's what the unit of molar mass. Okay. So if I just solve this, it is going to be 38.83 gram per mole. Right? That's what the molar mass of the mixture. Cool. Okay. What do I need to calculate is mole percentage for CO and CO2. Let's say the moles of CO is A. Or let's assume that total moles are 100, right? And if moles of CO is A, then moles of CO2 will be 100 minus A, right? I need to calculate the value of A. See, I have the molar mass of the mixture. The formula for moles is given weight by molar mass. So molar mass will be weight by moles. So molar mass of the mixture will be weight of the mixture into moles of the mixture. The total moles of mixture is assumed to be 100. This is the total moles of the mixture. Okay. Okay. I need to calculate the weight of the mixture. Okay. So if I assume the moles of carbon monoxide as A, then the weight of carbon monoxide will be, carbon is like 12, oxygen is 16, 28A. How this is 28A? See, moles is given weight by molar mass. So weight will be moles into mass. Moles was 28. Molar mass was, moles was A. Molar mass was 28. So given weight will be 28A. Makes sense? Weight of CO2. The moles of CO2, 100 minus A into the molar mass of CO2, that is carbon 12, oxygen 16 into 2, 32 plus 12 is 44. 44 into 100 minus A. Now I am going to put all these values into this equation. This is what? This is your mass of mixture. This is W mixture, right? Okay, okay. Let's put the value. Molar mass of the mixture is 38.83 equal to the total mass of the mixture 28A plus 44 100 minus A upon the moles of the mixture. The assumed moles are 100. So let's put 100 over here. If you just solve this, so if you multiply 38.83 with 100, it will become 3883 is equal to 28A plus 4400 minus 44A. Subtract 2844. 16A is equal to 4400 minus 3883. 10 minus 3 is like 7. 9 minus 8 is 1. And 13 minus 8 is like 5. 517. So A will be 517 by 16. Wonderful, wonderful. So if I just calculate this, 16 into 3 is like what? 48. 48. 37. 16 to 32. 50. 50 is like what? 57 is like 48. Again, somewhere around 32.3, right? That's the value of A. If you need to calculate the mole percentage of carbon monoxide, it will be moles of carbon monoxide upon total moles of the mixture into 100. If you just put this value, moles of carbon monoxide is like A, right? And the value of A is 32.3 upon total moles 100 into 100. So the answer is nothing but 32.3%. If mole percentage of CO is 32.3% and there are only two gases present in the mixture, can I say mole percent of CO2 will be nothing but 100 minus 32.3? And this is going to be like what? 0.3727, 67.7%. Let's look at the options now. If you just go back to the question, 32.19, 67.81 is the closest possible answer for CO and CO2 respectively. So yes, A for Agra is the right question. And if you rate this question on the difficulty level 3, the difficult, 2 the moderate, and 1 star as the easy, so I will mark this question as a 3-star question, right? It's a difficult one. It was a nice question. Good for the practice. And with that, we close this question. Alright, so here we have a wonderful question and with a graphical interpretation in that. Let's see how we're gonna deal with this question. So the question is talking about PCl5 gas that is dissociating into PCl3 and Cl2, and slope of the linear curve is such that this is the value given. If you remember from your 10th standard, slope of a line, slope of a linear curve is nothing but tan theta, right? And the value of tan theta from here is minus 2.1. Okay. What is there on the y-axis? You have log k base 10. What is on the x-axis? You have 1 by t. Okay. We have to figure out the delta H naught value. Okay. Okay. If you just remember, the formula for delta G naught is delta H naught minus T delta S naught, right? And the another formula for delta G naught is minus RT ln K equilibrium. If I just convert this into natural log into log base 10, why? Because there is log base 10. So minus 2.303 RT log K equilibrium base 10. Make sense? So let me equate this equation with this equation. So I'll say that delta G naught will be equal to, whether I will write it as delta H naught minus T delta S naught is equal to minus 2.303 RT log K equilibrium, and the base is 10, of course, right? No need to write it again and again. Let's modify this equation into what is required. On y-axis we have log base 10, on x-axis we have 1 by t. So I will write it as delta H naught minus T delta S naught is equal to minus 2.303 RT log K equilibrium. That's what the equation is. So let me take log K equilibrium on one side, right? I'm going to convert this equation into a linear equation with y as log K equilibrium and x as 1 by t is equal to minus delta H naught upon 2.303 R into 1 by t, right? Okay, okay. And what else? This will be like plus T delta S naught upon 2.303 RT. So T will get cancelled with T. Let me remove T from here, T from here. This whole term will be nothing but log C, right? Okay, okay. Or y is equal to mx plus c. If I compare it, this equation with y is equal to mx plus c, right? Fine, fine. Now your y is log K equilibrium base 10. Your x is 1 by t and the slope is minus delta H naught upon 2.303 R. And the slope is given as minus 2.1. So from here I can say delta H naught is nothing but 2.1 into 2.303 into R. And the unit is joule per mole. So I have to replace R with 8.314. Cool. Okay, okay. So let's take the approximation 2.1 into 2.3 into 8.3. Fine. So I'll write it as 2 plus 0.1 into 2.3 into 8.3. So this will like 2.3 into 2, 4.6. 4.6 plus 0.23 into 8 plus 0.3, or let me write it as 8.3. Otherwise, you might get confused. So 4.6 plus 0.23, 4.83. 4.83 into 8 plus 0.3, right? So if I just solve this further, what will I write? I will write as 4.83 into 8 plus 0.3, right? This is what I need to solve. So 8 3 24, 2 8 8 64, 6 and 8 4 32 and 6 38, 38.64 plus 3 3 9, 3 3 is 9, 8 3 24, 4 3 12, 14 after 3 decimal places. So this will be like 39 point or somewhere around 40. So 9 4 4 8 6 4 10 8 9 10 40.089. What is this value? What we were calculating, delta H naught, joule per mole, right? That's what the delta H naught is. Let's look at the options. 40, the answer is 40.089. Can I write it as 40.1 joule per mole, right? This is your delta H naught value. If you look at the options, oh my god, options look dirty. Let me remove this part. So 28.72 no, minus 28.72 no, incorrect. I hope you can see the right answer to this question. That is 40.2 joule per mole, very close to what we have calculated, 40.1 joule per mole. So if you want to rate this question on a difficulty level 3 star, a difficult question 2 star, a moderate question and a single star and an easy question, I will rate it as a 3 star question, a wonderful question, a very good question for the practice that we have done right now. With that, we conclude this question. Thank you. Alright, so look at this question. This is like from the gaseous states of matter, right? Okay, and the topic is diffusion and effusion. Perfectly fine. We are given two gases, that is SO2 and methane, CH4. Fine. We are provided with the molar ratio, 1:2, molar ratio of moles. Let's call SO2 as gas 1 and methane as gas 2. Okay. Now, one more thing that is given to us is that the rate of effusion is equal. And at that point of time, they're asking the ratio of number of molecules. Okay. Okay. So the first thing, the rate, right? The rate of effusion. It depends on what? Think logically. Although we know it depends on pressure, it depends on temperature, it depends on molar mass, it depends on the velocity. There are so many things. But in this frame of questions, it is going to depend on the pressure, right? If the pressure of the gases is high, the rate of effusion is going to be high. So directly proportional. Okay. This is one thing. It also depends on the molar mass. If the molar mass of the gas is high, then the rate of effusion is going to be less. Heavier gas is going to move slowly, and the rate depends on the molar mass, under root of molar mass, square root of molar mass, and that is inverse relation, right? Higher the mass, lesser will be the rate of effusion and diffusion. Cool. If I just combine this, I'll call that the rate depends on the pressure and the under root of molar mass. Cool. Fine. But we are talking about the molar ratio. Okay. Okay. And we are talking about the molecules of the two gases. Now, this pressure has to be somehow linked with the moles and the molecules, right? So can you just comprehend this thing that pressure is directly proportional to moles. PV is equal to, if you just use the ideal gas equation, PV is equal to nRT. We know that at constant temperature, the pressure is directly proportional to moles, and moles is obviously directly proportional to number of molecules, right? Number of molecules. So can I just say one thing very clearly, that pressure is directly proportional to moles, which is directly proportional to number of molecules. I hope this point is crystal clear. No problem in that. Cool. So if I just take the ratio of pressure 1 by pressure 2, we call SO2 as gas 1, we call methane as gas 2, right? So that will be equal to the ratio of moles of 1 and 2, and that is going to be equal to the, let's represent number of molecules by capital N, N1 by N2. Make sense? Okay. If rate 1 is equal to rate 2, can I say rate 1 by rate 2 is equal to 1? The ratio of rates will be equal to the ratio of pressure into the inverse of molar mass, that will be square root of M2 upon square root of M1. Make sense? Okay. Okay. You know the molar mass of SO2 is going to be what? Sulfur is like 32 and oxygen is 16 into 2, 32, that is 64. Okay. And what about your methane? Methane is like carbon 12, 4 hydrogen 4, 12, 4, 16. Okay, okay. If I just put the values, let me replace P1 by P2 with N1 by N2. I'll do that. This is equal to 1, right? So N1 by N2 is equal to, let's put the values for molar masses. M2, 2 is your methane, molar mass 16 under root 16 upon molar mass 1, 1 is your SO2 under root 64. Oh, simple calculation. Thank God we are not going to trouble with the under root values. These are perfect squares. So the N1 by N2 value is going to come out to be, N1 by N2 will be 64, under root 64 is like 8 and under root 16 is like what? 4. So no, I'm not cancelling it. So this is like 1, this is like 2 if it goes on the other side, 2 by 1. The ratio is coming out to be 2 by 1. What is this ratio? What is your N? Number of molecules. So the ratio of number of molecules of SO2 to the ratio of number of molecules of methane, when the rate of diffusion is equal, then the ratio is 2:1. Let's look for the options now. 1:2, 2:1. Don't get confused. It is SO2 and then methane. So 1 upon 2. That means not 1 upon 2. That means the number of molecules of 1, that is SO2, upon the number of molecules of methane. The ratio is 2:1. So the correct answer is option B. B for BYJU'S or B for Basir is going to be the right answer. Thank you.